Okay, I'm recording now and um, oh my goodness. I think we have storms coming in, and I think that might be part of the issue. Okay, can you guys, you guys are gonna have to talk when I ask you, but can you guys see Moodle right now?
Yeah.
Okay, perfect. Am I not breaking up? Can you hear me okay?
Yeah.
Okay. I want to return the router booster. That's all I can tell you. That was a waste of money. All right. So out here on Moodle, I walked through how to do the thing with the amines, the carboxylic acids. I didn't record a video yet for esters and amides, only because that was on campus and I just hand wrote it. But I get that these are confusing. As we go, they get to be more complicated, right? So let me just start going through some of the things that I have that I've already even done. And then when you watch the video, it might be a repeat. Okay. So can you guys see my cam, my giant hand cam?
Yep.
Awesome. All right. Thanks. Okay. So amines, they are nitrogen containing compounds. And this is where it gets to be a little more confusing trying to figure out, and I've got the thing in front of me here with the review topics, and I am just going to kind of point out right now that on the review topics, is Raya out here? She asked me about it. Hold on. Raya's not here yet. Okay. I was asked why I put draw Lewis structure. Did you guys see that?
Yeah.
Okay. That's from days of old, from the beginning of a semester. You guys know how to do that. I needed a couple filler questions. You're going to find a couple that you're like, I think that's from a different semester. I wanted to just sort of boost up the number of questions to try to kind of help you guys. You know how to do this, bonding rules, you know how to draw Lewis structures, right? You have that sheet from before. If you need any like extra help on that, I will post the one that I had in 131, right? So those of you who had me in 131, remember I had that where I walked through how to do it?
Yeah.
Okay, I will post it out on our site too, if you want me to, just as a refresher. Not a big deal, but there's one, it's nothing. It'll probably be like an amine or something. You've just got to, you know, the bonding rules with nitrogen and hydrogen and all that, okay? The second option down where it says classify, draw, and name amines. I just took a bunch of questions and pushed them together with the idea of what you need to be doing, okay? So this is where I'm going to go back to that video I posted, and I want to show you when we are drawing amines, we can have primary, secondary, and tertiary amines, okay? So you guys, I'm back on my giant hand, right?
Yep.
Yeah, we see.
Giant hand, okay. So if we are drawing, and I'm gonna try to copy what I put out on Moodle, just so that you can sort of refer back to it, okay? When we're looking at primary amines, and it's a little different than when we were doing the primary alcohols, right? Or secondary or tertiary. We are looking at how many carbons are connected right to the nitrogen. Whoever wrote these rules, a little bit backwards, they didn't say, oh, let's look at how many this one's attached to. They don't. This is not how it works. So where we had a primary alcohol, right? We looked at the carbon that the O was attached to and how many carbons this guy was attached to. So we had to look at one. Right now, we're just looking at how many are directly attached to the nitrogen, okay? These look too similar to be able to say, not so sure what you're telling me here. Let's look at a secondary. Okay, so this is a secondary amine. I'm going to draw a secondary alcohol. Okay, look at the amine. How many carbons is this nitrogen attached to?
2.
Right, 1, 2. How many carbons is the oxygen attached to? Answer what I'm saying, then I'm going to go beyond that for this answer. How many carbons is this attached to?
Just 1.
Just
Not
1.
1.
This 1 is attached to how many?
2.
2. Right. Okay. So hold on. I've got a chat. 1. Thank you. Yay, Kareem. Okay. Right. So the difference here is on the amines, you're looking at how many carbons are directly attached to a nitrogen. When we're looking at the alcohols, it's different. You're looking at the carbon that's attached to the oxygen and how many are directly attached to that connected one. Okay. So this is where it's a little bit different. I didn't write the rules. I just have to teach them. Okay. So if you're looking at a tertiary nitrogen, how many carbons is this nitrogen attached to?
3.
Okay. 1, 2, 3, right?
Yeah.
Oh my gosh, you guys, I have a huge thunderstorm that just started here. So I'm guessing that is what was going on with the internet. If it goes out, don't worry, I will record something for you, okay? Just
It's
anyway.
raining next to you?
Oh my God, I have a huge thunderstorm going on right now. I'm in Royal Oak. I'm around the 16-mile Coolidge Crooks area. So I'm like about 45 minutes from you guys, okay?
Oh, okay. Yeah.
Just wait, it's coming your way. Okay. I know, more rain, more whatever, but whatever. So if I lose you guys, that's what's going on, and I will try to do something to try to help you some more, or maybe we can hop on here again sooner than Thursday, okay? All right, so when you're looking at tertiary, and you're gonna have to be able to draw this on the exam, you wanna be able to, or identify it, I'm not sure which one it'll give you. You wanna be able to say, okay, the nitrogen is directly attached to 3 carbons, right?
Yeah.
Okay. The other really cool thing when you're looking at this, and this is another pattern that helps some people, how many hydrogens are on a primary? How many hydrogens right here? 2.
2.
Right? So nitrogen wants 3 bonds, right? Here's the
Yeah.
1 bond, 2 hydrogens. How many hydrogens are on a secondary?
1.
1. Nitrogen is attached to 2 carbons, 1 hydrogen, 3 bonds. How many hydrogens are here?
3.
None. None.
Oh, no.
0. So nitrogen is attached to 3 carbons, none. You got to think about nitrogen and bonding rules. And this is why I threw that Lewis structure question in there for a bonding rule thing. But this, if you look here, there's no hydrogens attached. It's a tertiary. 1 hydrogen, it's a secondary. 2 hydrogens, it's a primary. So it depends which seems to make more sense to you, right?
It makes sense when you look at it like going down.
Doesn't it? Okay, so sometimes this is a better way to separate it out from the silly alcohols that play by a different rule, right?
Yeah.
Okay, so if you can look, and if ever you see NH2, oh, that's a primary. You see an NH, oh, secondary, oh, no hydrogens, we know it's a tertiary. Okay, this is going to help you if you recognize that when we get into the reactions, because if you looked through my video, when I talked about forming the salts, the ammonium salt, and I got into quaternary, that was a weird one, right? But all that was we were adding in an extra hydrogen here. So, and I'll get to that too. I'm not going to write it down because I don't want you to like get confused. We'll go through the process of this. But does this make a little more sense?
Yeah, it does.
Okay. Oh my God, I have sideways rain outside here. You guys are in for it. Okay.
I just checked the weather for Canton and it says 90% at 8 p.m. So it's coming.
Oh my God, you guys, this is absolutely sideways crazy out here. I'm on the 2nd floor. I have a condo that's got 2 stories. There's literally water flowing down in the parking lot where my car is. It's great. Okay. All right. So with keeping those separated, whoever's going to watch is going to be like, all right, I do the squirrel moments where I kind of go all over the place, and you guys know that about me by now, but whatever. There's a couple different, you have to differentiate between a couple types of amines. So there's something called an aliphatic amine and an aromatic amine, okay? So aliphatic, okay?
Oh, guys, that's the first question on lab 16.
Okay, so watch this. Woo, watch this. All right, I'm going to help you answer it. So there's an aliphatic amine versus an aromatic amine. It's super easy. I have no idea why I just made a capital A with that. you'll see me mix capital and lowercase letters and it drives people crazy. I'm trying not to do that, but whatever. Okay. Aliphatic amine. What that means, okay, so here's my benzene. If I have, like, let's say a CH2, an N, a CH3, we'll throw a CH3 up here, okay? Aliphatic means that this nitrogen is not directly attached to the benzene ring. That's all it means.
Okay.
So it could be either a secondary or tertiary.
It doesn't matter. Aliphatic
Matter.
just means it's not directly attached. Aromatic means it's attached. So it's either attached or within the ring, okay? So I could have an NH2. You guys, and I've seen it on a couple of the examples when I kind of scrolled through for the exam, I've seen somewhere they throw a nitrogen in the middle here. The nitrogen, it can absolutely go in the ring. There's no big deal with that. But if it's directly attached or within the ring, it's aromatic. So think aromatic. You're gonna have to think of it however you like remember it well. I try to think of the aromatic as being like a complete ring, and it's got to be attached or within. Aliphatic doesn't play that way. So however you guys can remember it, okay? You've got to be able to come up with something. What I like to do, and you're gonna laugh at me, is I look at the O and I think of the ring, okay? If that helps you, I think of it as a complete ring. It's within or attached to a circle.
I got it.
I'll probably look at this now and go, that doesn't make sense, but I get what you just said and I see what you told me. Okay.
Got it. Yep.
Okay. Oh my God, the thunder and the lightning. You guys, this is crazy. This is fun. I hope the power doesn't go out. I live in kind of where the power lines are buried, so I very, very, knock on wood, rarely lose power. We really do not lose it here. So we'll see how this goes. Okay. So if you're being asked, back to the thing for the exam, to classify, draw, and name the amines, you guys should be able to draw a primary, secondary, tertiary. You should be able to identify it based on how many carbons the nitrogen's attached to. You should be able to look, and I think the OWL homework, I don't know if the exam does it, actually combines these, where it'll say, is this a, secondary, and is it aliphatic or aromatic, or is it whatever? So I actually pulled a couple questions off of OWL. When I get done with some of these amines, I'm going to go through this and show you a couple, okay? I don't want to rush through amines and carboxylic acids and the esters, amides, because there's so much information. I want to make sure you understand this. If I need to record another video to help you with the other ones, I absolutely will, okay?
Okay.
Wow, thunderstorms. Thanks for humoring me and saying okay. Thanks. Okay. All right. So when we're naming, I'm like, okay. Look at the nomenclature. So nomenclature follows the same stuff that we've been doing, where we're going to name the longest carbon chain that contains the functional group. So in this case, we're looking for, when we're naming amines, we want to look for the nitrogen, right? Okay.
Okay.
So, all right. We want to look for the longest carbon chain that contains the functional group we're talking about. So it's the amine. We want to look and name the side chains. We want to number in a way to put the functional group at the lowest number, right? Then we want to put it into we want to assemble it to a name. All right. So the thing with this, these are all single bonds. Is that saturated or unsaturated?
Saturated.
Saturated.
Saturated or single bonds, okay? So if it was saturated single bonds, the normal name for this would be pentane, right? If we were ignoring the NH group, right? Okay, right? Meth, eth, prop, bute, pent. I hope you guys, by this point, you guys are counting like that, right? By now, right?
Yep.
Okay, say yes, whether you are or not. Okay. All right, so when we're looking at an amine group, the E is going to go away, and we're going to be adding in amine, which is awesome because it's the name of the functional group. That makes it actually kind of easy. A little
Okay.
easier, I guess. I shouldn't say easy because I know it's not. I say it's not. But let's count. We want to put this at the lowest group we can. So we're going to go 1, 2, 3, 4, 5. Pentane becomes pentanamine.
Oh.
Okay,
Okay, I
does
see.
that make sense?
Okay. Yeah, that makes sense.
Woohoo! Okay, so if you were given a name, pentan, right? Amine, you can look at this and you can say, okay, I know it's an amine. There's going to be a nitrogen group in here based on a 5-carbon chain, pentane. You can break these apart, but I'm not done. Okay, where does our amine group fall? What carbon?
On 2.
Okay, what's our side chain?
We have a 4-methyl.
Okay, put it together. 4-methyl, 2-pentanamine. Okay.
Yeah.
All right. Primary, secondary, tertiary.
It's primary
Why?
because the nitrogen is only attached to 1 carbon.
Okay, cool. Or it has 2 hydrogens, right?
Yep.
Okay, perfect. Primary. Okay. Then another one. Without even naming it, is that primary, secondary, or tertiary?
Primary.
Primary?
Primary.
Primary. Perfect. Okay. What is the parent chain?
Pent.
Pent. And it's
Pentamine.
cyclo, right?
Cyclopentanine.
Right. Cyclopentanamine. There's a lot more syllables. Okay. Cyclopentanamine. Tell you what, you guys are gonna be awesome at playing Scrabble when you get done with this class. All I can tell you, it's like, no, really, that's a word, and it like goes across the board. Okay, I've done it before, and people look at me like I'm crazy, but it's like the word. Okay, so cyclo, pent, 1, 2, 3, 4, 5. We don't have to say where it is. Why? Why don't I have to say it's a 1?
Because isn't it a part of the whole structure?
Well, it is. It's the only thing it's attached that's making us know it's an amine. So we know it automatically is attached to carbon 1. Right?
Okay.
Okay. All right. Let's look at another one. And again, these are all in that video, but this will help you kind of get through. And if you look at the video, repetition is really good, right? And I know you guys see me draw it like this all the time with those little like slashes. As a side note here, you can actually go like that. You'll see it in your book. That actually is the same thing. Okay, so it's not wrong if you drew it with a circle. I'm used to doing it like this. It's the same exact thing because what this is doing, and I know it mentions in the book, but I don't point it out too often. You are, this structure is alternating between single and double bonds, and it's going so fast that it actually creates almost this flow where you can represent it with a circle because it's just alternating, if that makes sense. Doesn't make sense to everybody, so I just tend to draw it out like this because this you guys are looking as a what? What is the side group as a benzene? What is this?
Phenol.
Phenol, right? So you're used to looking at it as a phenol or a benzene or whatever you're looking at. Your book and OWL, I don't know if I know your book will mention it like this or draw it like this. I don't care either way. It's the same thing, right? So if you wonder if you see this, it's the same thing as that. Those are identical.
Okay.
All right. So now we have got, let's look at our longest carbon chain. Well, I'm going to go right to left. I'm going to go 1, 2, 3, 4, 5, 6. Meth, eth, prop, but, pent, hex. Okay, I see a hexane chain because there's no double bonds. Should I be labeling right to left or left to right?
Left to right.
Why?
Left to right.
Why?
Because you want to put your functional group at the lowest number.
Perfect. So I'm going to go 1, 2, 3, 4, 5, 6, right? So this is going to be hexane. Now, if I go based on what I told you up here, it should be hexanamine. but why is this not hexanamine?
'Cause you got two NH2 groups, which
You
is
got it.
di.
So what's it going to be? It's a di, right? So the parent is hexane diamine. Tell me if you guys don't get that. Does that make sense?
Wait, can you repeat it?
Absolutely. Hexane diamine, the parent,
Okay.
as Hussein was saying, we won't go left to right to put this one at the lowest, right?
Okay.
This is
Okay.
an amine group, right?
Yes.
Okay, so we have got one amine group. Oh, we have two
Two.
amine groups. So
Okay.
it's a diamine, hexane diamine. We keep the E in there because, and you guys, organic chemistry is a little weird with their naming. They try to make it easier to say out loud, okay?
Yeah.
If
Okay.
we just had hexane diamine, it wouldn't quite work, right?
Okay.
So you're going to see somewhere the vowels will be contained in it, just because it flows better.
Okay. Got it.
Okay. Now, what do we have to say? We have to say where the two amines are. Where are our two amines?
2 and 3.
2
Right.
and 3.
So we have 2,3. I'm just going to put that like that. What else do we have involved?
A 5-phenol.
5-phenol. Okay, put it together. What comes first? 5-phenol.
5-phenol, 2,3-hexane diamine.
Awesome. Is it aromatic or aliphatic?
It would be.
I know,
It's
go back to your
attached.
notes, but yeah, what do you think it is?
I think it's aliphatic
It's aliphatic. Why?
or cream
It's
size.
a-
Aliphatic.
It's attached. It's not attached.
Good
Because
job, Kareem. Okay, it's because it's not attached. Aromatic, think the O. Remember my aromatic? Think that O. Picture this is the O. Right? If it was aromatic, it would be directly attached to this or within this.
So if I draw the O where you drew the little dots, it means the same exact thing, right?
No, not necessarily. Hold on. Let me go back to this. Let me just look at this, and I'm not sure if I'm understanding it correctly. I'm thinking not. Tell me if this is what you meant. If you were to draw the NH2 attached to this or within the ring, the N, if the N was in this would be aromatic.
Okay.
Okay. But what I'm just trying to tell you is the way that I learned, I try to pick things apart where I can look at it, the word, to try to help myself remember it. Right? I look at the O in aromatic. There's no O in aliphatic. The O means that to me is like it's attached or within a circle, the ring.
Okay.
It's up to you if that helps you or not, or however you want to do it. You can think aliphatic is not attached. To me, this I automatically look for that O.
Okay. Can we go back to the 5-phenol one?
Yep,
Because I'm not-
yep.
Okay, but you guys said this one is aliphatic.
It's aliphatic. The nitrogen is not directly attached to the benzene ring. It's nowhere near it.
Okay. Yeah, that's where I got confused because in the first when we drew the one for aromatic, it was attached like I don't know. It looked the same with the you know what I mean? Like
Oh
right
yeah,
here,
yeah,
you
yeah. I get it.
that's where
So,
I got
like,
confused. But
so
when
you
you
want
said
the
it's not attached.
nitrogen, but the nitrogen has to be directly attached to one of the carbons that's within the ring, or
Yeah.
the nitrogen can actually be. I have an example where the nitrogen is actually in the ring. So it could be like this, and I'll show you this in one of the reactions.
That's where I got confused because when I seen it, when I drew it, I pictured that, and that's where I got confused.
So you might have a nitrogen. Wow, that didn't work. Hold on. That's better. Okay, let me just, I tried to like draw over it. So you might actually have a nitrogen within the ring, right?
Mm-hmm.
So this would be aromatic or aliphatic?
Aromatic.
Aromatic, okay?
Okay.
Those are not as important, but I know Owl asks you. I personally, as long as you can tell the difference, don't go into it too much. I noticed that OWL asks you a lot, okay? I went through a lot of your questions today, trying to figure out how best to help you,
Okay.
okay? All right, so one other one I want to show you. All right, and it's already 7:30. This is holding up really well so far during the rain, and I have a feeling we probably are going to be on here a little more than an hour. So if you can't stick around, just look for the recording, okay? But because we're still only on the amines, right? Okay, so if I have this, what is that? First of all, is it a primary, secondary, or tertiary amine?
Kareem
Is it-
said secondary amine.
It is. Okay, Kareem, I keep seeing your answer after everybody else answers because I have to go like actually to another spot and click on the chat. I'm sorry. Yes, you're on top of it. Okay, so yeah, it is secondary, right? Okay, what is the parent chain that includes the functional group? Longest parent chain that includes the functional group?
Pro. Would it be pro?
Meth F prop bute.
Bute,
Meth F prop bute. So what would that be? If it's not butane because it's an amine, what does it change to?
Butanamine.
Right. Butanamine. All right. Where is the amine group located? Am I going to label left to right or right to left?
Left to right.
I feel so bad. I know you're trying to like participate. Hold on. I wish there was a way I could like keep the chat like open. Oh, yes, you're right there. Okay, sorry. Okay, so it's left to right. Where is the amine group?
At 2.
2. Okay. Now, remember our weird structures where we had like the hydroxyl group or a methoxy with a methyl coming through an oxygen? Okay, yeah, you're doing really well with this. Okay, I'm playing with the chat. This is it's an N-methyl, which means the methyl is coming through the nitrogen. Okay. So it's going to be a capital N methyl for the side chain. It shows methyl coming through or connected to that nitrogen. So you see the methyl here? And you just want to put it together. So it's an N methyl to butanamine. And this is a secondary, right?
Yep.
Okay. These are kind of weird, but so far we've seen hydroxy, we've seen methoxy, right, with a methyl coming through an oxygen. We've seen isopropoxy. Anything weird coming through an oxygen has that oxy. This is a little different, and we're trying to say it's a methyl coming through the nitrogen. Again, I didn't write this. I did not develop these rules, but once you understand it, when you see this capital N for the nitrogen, it's a methyl coming through it. Okay. Like I said, I did not write this. All right. What if we have what do I do with that? What's the longest parent chain?
Hex.
Yeah,
Hex is the longest chain.
it's hex, so it would be hexanamine, right?
Yep.
Okay. All right. Oh my gosh, Kareem, I wish you were talking. You were like faster on the chat than I am. Okay. So are we going to label left to right or right to left?
Right to left.
Okay. So meth, F. What comes next? Prop, bute, pent, hex, right? So what is the parent name?
Would it be two? I know the number would be two. It'd be 2-hexanamine.
Yay, okay, awesome. 2-hexanamine. Alrighty, what do I have at 3?
Isopropyl.
3-isopropyl. What do I do with this? First of all, primary, secondary, tertiary amine.
Tertiary.
Why?
Because it's nitrogen is attached to 3 carbons.
You got it.
No hydrogens
Okay.
as well.
So what do I do with that? Yeah, no hydrogen either. So how do I like write that out?
Would it be N-dimethyl?
Close, absolutely close. And before I say it, I'm going to come over here because I think she's already. And you know what? You're absolutely right, Cream, except you need capital N's. You're perfect, but it needs to be capital N's, okay? So what it is this is going to be an NN dimethyl. So it's going to be 3-isopropyl. And I believe Owl wants capital N's. I require capital N's. So if I might be different on this. I don't believe so. So it's in 3-isopropyl because I comes before the M in methyl, right? Di doesn't get counted in alphabetical. So 3-isopropyl, NN dimethyl 2-hexanamine. These are getting more crazy as we go, right? Good news is we're almost done with functional groups and we'll get into biological things, right? When we get into the biochem, we're almost done with the functional groups, okay? You guys okay with this?
Professor, when you named it, you put isopropyl first with alphabetical order. How'd you write it out?
So isopropyl, the iso actually gets included when you're alphabetizing. Di, tri, and those others like tert and stuff do not. So I comes before M.
Okay, I got it.
Okay. Yeah, there's a couple sheets that I've written this down on, and this is one of those weird rules. ISO is one of the ones that gets included. Okay. Again, didn't write the rules. I would have made it more logical, but not my thing. Okay. I'm just repeating it. Okay. Covering structures with ketones and carboxylic. Hold on, Cream, just a sec. Will we be covering structures that contain both ketones and carboxylic acids? All right, let me answer this question. So I don't know if you guys can see the chat, but one of your classmates is saying, will we be covering structures that contain both ketones and carboxylic acids? Yes, I can give you an example. Here's the deal. You guys, I gave you a sheet with naming priorities, okay? Carboxylic acids take the highest priority. If you see a carboxylic acid in a structure, that is what is going to be named. And this comes with practice and with looking at the sheet of the naming priorities. Should you know this at this point? Not yet, because we're not through all the groups and this is super fast semester, right? So I put a sheet out there with that. But is that what you're asking me, Krim? Is that you want to know like the difference? No. But does that make sense? Okay. You're not the only one who has asked this. I have had questions with like, if you get a giant structure, even if it's a pretend structure, and I'm throwing alcohols and ketones and aldehydes and carboxylic acids and everything on there, carboxylic acid wins hands down. That gets the top priority. Okay.
So the carboxylic acid would have the parent name and everything else would be a sidechain?
You got it. So if we go out here and look at this, can you see Moodle?
Oh yeah, we can see it.
Yeah, I could see it.
Okay. Right here, functional group by priority for naming. I don't know if you know it's out here. It's tiny. And what I did
Oh, I
is
didn't even
left,
see that.
see, I left space next to it so you could write in, but this is the list of priority or functional groups from highest to lowest. So carboxylic acid wins hands down. You guys have seen esters. amines, aldehydes, ketones, alcohol styles. We're almost done with all these, right?
Yeah.
Yep.
Amines, ethers, alkenes, or alkyne, alkene, alkane. This is how it goes. Alkanes get the least priority, okay? Does it show what side chain would be? The side chain, Kareem, I'll answer that when we do let me put together an example of a gigantic one, okay? And I'll just sort of show it to you guys in a separate video. Is that good? So I can kind of show you where you pick the names apart.
Actually, yeah, if you can make it a separate
Perfect.
video, that'd be great.
Yeah, I will. Okay, and she said yes too. Okay, so if we're, let's see. Okay, so if you're looking at this, carboxylic acid wins hands down, and there's reasons for that. Let me go into that in a separate video, okay? And I will
Okay.
give you guys, I know Raya has asked, Raya's still not out here, right?
No, she's not in here.
No, Raya. Okay. So I know that Raya has asked me about it before. And it's a question that should come up if you're paying attention, which is great. I'm so glad you guys are asking me these questions. Because at some point you're going to be like, which one do I pick? If you see a giant structure, which do I pick? Let me put a few together and see if we can have you guys, I'll pick them apart in a video. I think it's probably the easiest way, unless you want me to put them up there and see if you can do it. And then I can give you the answers, and it won't be graded, but which way would you rather see it?
If you can make a video of it and upload it,
Yeah.
tomorrow and Thursday when we have another Zoom, we could actually try it by ourselves, but I would like to try them right now as well.
Yeah, okay, absolutely. Let me see what I can put together. I'll put something together tomorrow with, I don't think this is something you will be asked anywhere in the near future unless it's closer to the end, like with the functional groups and maybe a final exam type of question. I don't see
Yeah.
where they'll be doing this, right? Have you guys run into this at all on OWL?
I haven't even started owls yet.
That's a fair answer.
No, it's on the I think Kareem's right. I'm looking at chapter 16 report and it has that chart thing.
Oh, the actual report itself that I made? Is that what you're looking at?
Yeah, fill in the
Oh,
chart of
All
INI.
right, hold on. All right, if it's
Yeah,
something
so
I
it's
did, then I need to
phenol,
explain it.
thiol, 1 amine, 2 amine, 3, and then carboxylic acid.
All right, so this one right here on this report, this chapter 16.
Yeah.
Hold on.
Oh, no, 18 and 19.
Okay, that's gonna be better. All right, hold on. 18, 19. Okay. So this is what you're talking about. IUPAC name, functional groups. Is this what you're talking about?
Actually, no, it's 16.
Okay, I had that one open too. All right, 16. So we have our protonated, deprotonated, the structures.
Kareem said,
this guy
Yeah.
right here.
yeah, yep, this one.
Okay, all right. So you're not being really asked to name it, okay? You don't have to. There's extra credit if you only am asking for the molecular formula. So I'd love it if you could point out groups, functional groups you've seen. So of course I'm being silly saying circle the ether, draw an arrow pointing to the alkene, put a smiley face under the carbonyl. I do this kind of stuff, okay? What would the molecular formula be? I'm only looking for carbons, hydrogens, nitrogens, things like that, oxygens, and how many of them. This is tricky.
Yeah, I was confused. when I
But it's
see
something
it.
to look at. Okay, but see, okay, you're going to be looking at longest parent chain, right?
Okay.
Okay. You're going to be looking at, you could count the number of carbons. There's a lot of ways you could do this. You could count how many oxygens you see. That's why I put this as extra credit. Okay.
Kareem said in number 4, I'm pretty sure.
Oh,
Say it
Kareem said
again.
also number 4 on 16. I think Kareem wants help on naming the following structures.
Number 4 on 16. This?
Is that what Kareem was talking about? He said in the chat
This one?
number 4.
Okay, so here, if you're looking at Oh, I don't want to give this away. Let me record the video, and if it doesn't help you, then you let me know. How's that?
Okay.
Let me give you some tips on this and figuring out which one of these takes precedence and which one of these takes precedence. And if that doesn't help you, you let me know. Is that fair? It is
Sounds
fair. That's what I'm going to do. Nod your head. Okay. All right. What do you think you would do with this though? If you, I'm not going to go do that. I don't want to do this because this is something that you guys are supposed to try to figure out on your own. This one again, extra credit if you give me the molecular formula. It's not a big deal. I want you to be able to point the things out to me. Okay.
Yeah, Professor, with number 4, would we be looking at functional groups?
You would kind of have to, right?
Yeah, so Kareem said he knows the carboxylic acid takes the parent name. He's just confused on what we name the side chain for the ketone.
Right. But what is this structure right here? You have a carbonyl with 2 carbons. That's not a carboxylic acid, is it? That's a ketone.
Yep.
Okay. So if you go look over here, and this might help you. So we have a ketone. All right. What else do we have in there? I see an amide. I think amides take precedence. So,
Oh yeah, it makes sense.
okay. So kind of go back and forth between these two. See what you can do. If you still don't get it, let me know. Because that's my job, try to help you get it. But see if you can figure it out looking at this list and what is being shown here. Okay. We have a chloro group here. Chlorine is what, a halogen, right? We
Mhm.
have an amine. This is what, primary, secondary, or tertiary?
Tertiary.
Okay, we're still looking at the amine here. So if you look here, all the way down, I didn't even put halogens in here because they're like below all of this, okay? So it's one of those that if you can kind of match things up, it might help you a little. Okay. If not, please let me know and I will absolutely, this is where I don't get a lot of emails from you guys. You have to send me emails saying, oh my gosh, I don't get this. Please, can you record a video or please write out how to do this? I don't want you struggling and trying to spend like 3 hours trying to answer a question. Ask me. I can probably answer it in 10 minutes, okay? You're not bothering me at all. This is what I'm supposed to be doing is helping you. Okay?
Okay.
I was gonna say crickets. Nobody's answering me. No, but does that
Sorry,
make sense?
I muted myself so I could write down notes. And then
Oh, okay.
Yeah.
That makes sense, you guys. You would not be in my class if you knew how to do this,
Right.
right?
Mhm.
I always get so frustrated when students are like, I couldn't figure it out, so I looked it up or I did whatever. Don't do that. That's my job. I'm supposed to help you figure out how to do it.
Yeah, that's true.
You shouldn't know it. You should not know it. That's why you're here. And you're like trying to cram through a super fast semester. You shouldn't, but you're picking up on parts of it. So hopefully I can fill in the gaps.
Okay.
Okay. So with this, I mean, oh my gosh, you guys, it's already almost 8 o'clock and we've only gotten through nomenclature on this. Okay. Out of all of what we've been doing. This is why it's so hard to do in a short semester. So here's what I want to ask you. Would it help if I went through and recorded a couple of separate, I'm going to show you what I've got here. Here's my, hang on.
The storm has came to Canton.
Uh-oh.
It's
Okay.
here.
Big one as well.
Oh no. All right. So here is, can you guys see, this is our review topic sheet, right?
Yep.
What do
Yeah.
you guys see? Are you seeing my camera?
Yep.
Yeah, I see.
Okay. So Lewis Structure's bonding rules, you guys. I absolutely will throw out a help sheet on that. You should know this just based on bonding rules. Okay. I just threw it in as an extra question. Classify, draw, and name amines. We've done that. Oh my gosh, we still have 1, 2, 3, 4, 5, a whole bunch to go. Identifying functional groups. We got nowhere tonight, but identifying functional groups.
No, I mean, you clarified some things. You clarified a couple things. For us.
Okay, perfect. That's good to hear.
I mean, it's better than just nothing.
Yeah, absolutely. And Zoom, knock on wood, has been cooperating. So
Yeah.
what I'm thinking I should do is if I can break this up into number 2 and 4, okay? So the drawing, we've already done that. I'll do something with a video just on reactions, okay?
Okay.
Drawing and naming carboxylic acids and reactions, that's out on the video, but I will do another one just to see, just if it would help. Oops, I just lost that. I don't know if you lost it, but I lost it. Okay, I'm back here. Oh, it's because I'm trying to scroll and it's not letting me laugh amongst yourselves. I'm having technical issues. Okay. Then this over here, so drawing and naming and reactions. Identify, draw, and name amides, esters, right? And then the reactions. So breaking it down into those might help. But I do want you guys to go out here and just sort of take a look. There's so much stuff out here, you guys. Okay, so this chapter 16 amines, I recorded this on the weekend just in case Zoom didn't work, right? So it's kind of like what we went through, but it actually goes into the reactions, which we didn't even get to today. Carboxylic acids, I go through naming, I go through reactions. This one on the esters and amides, I hand wrote things out. I did not record it because I actually wrote this out at work when I was on campus, and we were having some technical issues there. Everything's technical issues, right? But if you guys look through this, there's several pages. There's 6 pages here. And what I can do is kind of go through and make a video explaining this. So you have a video with this, you have a video with this. I can make a video explaining this, give you a few more examples, and then you have to respond by like early on Thursday to let me know what I need to talk about Thursday on Zoom before your exam, because look at how much time we just spent going through naming, right?
Yeah, I think that's a good idea.
Okay, so watch this video, read through this. I'll make a video for this one. I'll try to make something that kind of sums it up a little. I have our little sheet here, and this is vague on purpose because there's how many questions? 23. There's only 8 topics, right? I didn't want to list every single topic because it kind of all falls within this. I thought this might be easier to look at. Okay. Okay. All right, but please, you guys, email me. Nobody emails me. Well, a couple of you do. Email me and let me know. How can you say, can you please just explain this in a video? It's very quick for me to make a video. It's not a big deal.
Okay. That's I also lack on that part. I barely
You what?
I said I lack on that part too. I barely ask and I just guess.
No, but you guys have to ask me. I don't know what I don't know. Is that fair? You don't know what you don't know. I can't read your minds. I try like on some of the things to point out this is where some other students have had problems, but I don't know where you are because you guys might understand something that somebody else never did. I don't know. So if you guys can just sort of help guide me and say, I need a video on this, I guarantee your classmates have the same question. And wouldn't you rather have extras out there than not enough?
Yeah, it would be better.
Yeah, so please don't think you're bothering me. This is what I'm getting paid for. I'm getting paid to help you learn in this absolutely insane world online, right?
Yeah.
Yeah, it's crazy. I prefer to do it in person too, you guys. So I'm still learning all of this. Like those of you guys have had me in 131, our labs, holy cow, right?
Yeah, they were tougher. They were more the videos they used to make and all that stuff.
Oh, it was crazy. And so I can't wait to get back to like doing this in person and helping you guys in person. But you know what? We're not there right now. So we have to make the best of what we've got right now. But that means that you have to ask me to help you because I can't it sounds horrible to say, but this stuff makes sense to me. So I don't know exactly what doesn't make sense to you. Does that make sense? right? I don't know where you're struggling until you tell me. And then I'm like, oh yeah, okay, here. I helped somebody else do it this way. Okay.
Yeah,
Everybody
you're right.
went quiet. Everyone went
Yeah.
quiet. Okay. No, it does. It makes sense though, because I know you guys want to get this. I get it. That's why you're out here. You're trying to learn. There are several of you, probably more than half this class is like super, super, super trying really hard, which is great. I love it. It's not easy. So I give you guys a lot of kudos here, you know, being able to do what you're doing so far. It's not easy. Okay, but let me know how I can help because that's why I'm here.
Will do.
Got it. Franks.
Thank you so
Okay.
much, Professor Hall.
All right. So it's been an hour. I need to go like sit. I can't do this anymore. But I will do it starting tomorrow. I'll record some more videos and then see if I can find some other resources. But I think walking through and doing them by hand where you can see me drawn and hear me, tell me if you disagree, but I think that's probably the best for you, right?
Yeah, that's true.
I agree.
Okay, perfect. All right, I will do some more. Okay,
Thank you, Professor Hall.
all right, you guys. Have a good evening. Hopefully the storms are out of here, so they're probably really over by you now. So
I just heard the thunder actually.
yeah, it's like,
It's pretty bad here.
yeah, you guys are in for it, but it only lasted about the length of this class, about an hour and then gone.
Well, it's saying it's gonna stop